Deep beneath the salt flats, powerful pumps extract lithium-rich brine from ancient underground reservoirs.
Pressure holding steady, flow is good. Roger that, monitor levels.
This brine is channeled into vast evaporation ponds where sun and wind begin the long concentration process. Over weeks, the brine moves through a series of ponds, growing ever more concentrated as water evaporates. When the lithium concentration reaches the right level, specialized equipment harvests the thickened slurry.
Levels are rising steadily, keep the flow constant. Fill complete, securing the hatch now.
Tankers carry the concentrated material across the desert to the chemical processing facility.
pH is stable, initiating precipitation.
Copy that, slurry looks good.
Discharging now.
The precipitate is filtered, washed, and separated to achieve high purity. The dried lithium carbonate is bagged and prepared for transport to battery material production.
Pull tight on this side. Got it. Ratcheting now. One more strap to go.
The loaded trucks begin their long haul toward the specialized battery precursor materials facility. Across hundreds of kilometers, the raw material travels to where it will become cathode and anode precursors.
Gate opening, proceed to bay 3. Clear on left, reverse steady.
Upon arrival at the materials facility, the lithium carbonate is ready for further refination. The bags are unloaded and fed into the next stage of material transformation. Inside the facility, the material enters automated refining lines for higher purity processing. The powder is fed into high-temperature refiners that further purify the lithium compound.
Sample extracted, running analysis. Purity holding at 99.5%. Sample sealed, ready for next stage.
Now purified, the lithium material is transported to the precursor synthesis stage for cathode production. The purified material arrives at the vast gigafactory where battery cells will be born.
Scan complete, barcode verified, documents match, proceed. Barrier clear, proceed to dock.
Inside the secure perimeter, the material heads directly to the dedicated processing wings. Bags are transferred onto internal conveyors for precise routing within the facility. Advanced air filtration and controlled environments protect the purity required for battery materials. Automated systems begin mixing the lithium with nickel, manganese, and cobalt compounds. These raw materials are combined in precise ratios to form the foundation of the cathode. The mixture enters reaction tanks where it will be transformed into cathode precursor particles.
The material enters highly controlled zones where cathode precursor will be synthesized.
After washing, the material is dewatered to prepare it for drying. The precursor mixture first undergoes thorough washing to remove impurities. Multiple washing cycles ensure the particles meet the extreme purity standards required for batteries. Vibrating screens sort the particles to ensure uniform size for consistent performance.
Adjusting vibration to optimize the separation.
Uniform particles are conveyed into industrial dryers for moisture removal. High-temperature drying produces a stable, dry precursor powder ready for calcination. The powder is cooled and sorted again before the critical high-temperature calcination step. In the calcination furnace, the precursor undergoes high-temperature treatment to form the final cathode material. The calcined material emerges as high-performance cathode active material. The finished cathode powder is stored in sealed silos, ready for electrode manufacturing. High-purity cathode powder is carefully retrieved from sealed storage for electrode production.
Adding carbon black now.
Scale reads 2.5 kilograms. Proceed. Binder next. Pouring. Batch complete. Transferring to mixer.
Intensive dry mixing creates a homogeneous blend ready for slurry formation.
Torque and time are on target. Discharge looks good.
Solvents are added to form a viscous slurry that will coat the electrode foil. The slurry is precisely coated onto thin aluminum current collector foil. Controlled drying removes solvents, leaving a solid and uniform active layer. Calendering compresses the coating to optimal density for maximum energy storage.
Final thickness 150 microns. Within spec.
Precision slitting cuts the electrode into exact widths needed for battery cells. Simultaneously, graphite anode material is coated onto copper foil in a parallel process.
Visual inspection complete. No defects detected. Applying protective wrap now. Moving completed cathode reel to transport. This cathode reel passes inspection. Anode reel is ready for wrapping.
Both cathode and anode electrodes are now ready for the core cell assembly stage. Electrode reels are delivered to the automated winding stations for cell formation. The jelly roll is inserted into durable metal cell cases with robotic precision. Cathode, anode, and separator are precisely wound into compact jelly roll cells.
Fill level optimal. Proceed to seal. Mist extraction active. Level stable.
The cells are hermetically sealed to contain the electrolyte safely. Initial charging cycles form the critical solid electrolyte interface inside each cell. Aging allows the cells to stabilize and reveal any manufacturing inconsistencies. Every cell undergoes rigorous electrical testing before being approved for use. Approved cells are sorted, palletized, and prepared for module assembly. The individual cells now enter the module assembly stage to form larger battery units. Automated systems now assemble individual cells into complete battery modules. Robots position cells and laser weld bus bars to create reliable electrical connections. Integrated cooling plates ensure efficient thermal management during operation. Protective enclosures and wiring complete the functional battery module. Each module undergoes comprehensive electrical and safety testing.
Module in place, pins locked.
Tested modules are integrated into full battery pack structures.
Alignment confirmed. Proceed with interconnects.
The battery management system is installed to monitor and protect every cell. The complete battery pack receives its final protective enclosure. Rigorous final testing confirms the pack meets all performance and safety standards. Charge cycle complete, no anomalies detected. Leak and dimensional checks passed, approving for shipment. And this is how modern factories produce electric vehicle batteries from start to finish.